Hi, so today's lesson is about graphing polynomials. If you're in my class, you're in section 5.1. But first we got to talk about what is a polynomial function. So far this year, we've actually talked about some polynomials already. So we've talked about linear functions. That is a polynomial. We've talked about quadratic functions, which is also a polynomial. And we've talked about cubic functions, okay? All of these are examples of polynomial functions. Now you may be asking, well, what about the absolute value function? The absolute value function is not a polynomial, and we'll talk about that later. But all of these are categorized by their degree or their highest exponent. So a linear function has a degree of 1. So remember, like y equals mx plus b. We look at that x, that exponent to the x is a 1. A quadratic function has a degree of 2, so something like y equals ax squared plus bx plus c. That 2 tells me that it's a quadratic. And a cubic function has a degree of 3. So those are all polynomial functions, but there's other polynomial functions. And so we should discuss what a polynomial function of degree n would be. So now in the book, you get this funky looking, crazy definition of a polynomial. A polynomial is basically, if you look at it, it's something that has a constant or a coefficient in front of it, which could be 1, and it has an x value raised to an exponent. Now, in order for it to be standard form of a polynomial, terms must be in order by their exponents, starting with the highest and ending with the lowest. And so you're always going to want to put your polynomial in standard form. Now, the ones we've been working at, we've always put them in standard form, so highest exponent going down. But now we're going to be looking at bigger ones. So again, always put it in standard form. That means descending order by exponent. All right. The degree of a polynomial is going to be the highest exponent when the polynomial is written in standard form. Okay, so write it in standard form and then look at the highest exponent, and that's going to be the degree. The leading coefficient is the coefficient or the number in front of the first term once the polynomial is written in standard form. Now remember, if I just put it like, I don't know, x to the 4th, its coefficient, although not written, is a 1. So just remember that that leading coefficient would be 1. But if it was like 2x to the 4th, then the leading coefficient would be 2. So it's whatever number is in front of the leading term. Okay, so let's try. So we've got this polynomial. I can see it's a polynomial because it has variables raised to different exponents, but it's not in standard form. So the first thing I'm going to do is I'm going to write it in standard form. So y equals 2x to the 6th, let's see, plus 4x to the 5th, and I might cross them out as I go, minus 3x cubed, minus 2x squared, plus 1, okay? So the leading coefficient, I look at the leading term. Once it's in standard form, the leading coefficient would be 2. All right, one thing I didn't mention is the constant term. We've talked about that. The constant term is the number that doesn't change, means doesn't have a variable with it, so the 1 at the end. So the constant term is 1, and this would be a degree 6 polynomial. Okay, so hopefully you're seeing that that's a pretty easy thing to distinguish. There are some polynomials and some that you already know that actually have names. So again, if it's a degree 1, we've said that it's linear. Okay, if it's degree 2, it's quadratic. Say that again. It's degree 3, it's cubic, and that's going to be something like y equals x cubed or f of x equals x cubed. And then the 4th is quartic. You may hear that from time to time as well. So y equals x to the 4th. All right, so hopefully you're understanding kind of what a polynomial is. Now we're going to relate this to some graphs. All right, so we're going to be looking at the end behavior of what we call simple polynomials. So a polynomial, you need to know, is a smooth, continuous curve. It also can be a line, but most of them are going to be curves. And a smooth curve is a curve that does not have any sharp corners. So you can see this has a sharp corner, so that's not a polynomial. A continuous curve, so we've got the word smooth down. A continuous curve has no breaks or holes in it. So right here you can see that there's a hole. and this one breaks off, like it's like goes to here and then it starts up back up here, and that's a break. So that's, again, that's not a polynomial. So think back to that absolute value function. The absolute value function looks like a V. Look, it has a sharp corner, so it is not a polynomial. So it doesn't meet the definition of the graph of a polynomial. All right, so what we're going to do is we're going to quickly graph the following functions. And today in class I showed you about Desmos, so I want you to go into Desmos and we're going to look at them. And then we're just going to quickly sketch them. So here's the first one. We put in y equals x, and it looks like we have a linear function. So we're going to sketch a linear function. All right, the next one we know, and we really should know what these look like. Y equals x squared we know is a parabola, so go ahead and just sketch a really quick parabola. Now, this week I introduced the new one, which was the cubic function. So we could see that this one has like a squiggle in the middle. I want you to really like focus on that little squiggle that it has. I call it a squiggle. And draw that on your paper. We're going to talk about them in a second once you have them all drawn. And then the last one I want us to look at is the quartic. Okay. Now you might notice now if you're looking at the quartic on Desmos that it's like flat at the bottom, unlike the parabola that like has a nice U to it. This is more like it's like flat at the bottom. So, all right, so let's go back and see what you've drawn. So hopefully what you've got, a quick sketch. Let me switch colors for the graph. You have a line and it goes through the origin because that's the parent linear function. All right, and then you've got the quadratic. So it looks like this, like that. You get the cubic. So if you haven't, and that's the one with the squiggle. So it goes to here and then it squiggles up. Okay, and I always have trouble drawing that one. And then the quartic. So a little bit similar to the parabola, but it's just a little bit flatter at the bottom. So it's like flat like that. Okay. All right. So this was a degree 1. Let's write that too because that may help us. A degree 1, a degree 2, a degree 3, and a degree 4. All right. So I want you to look at the ends. Okay, the ends, meaning this part and this part. Those are called it's called the ends. And see if you can notice anything about the end behavior. And I want you to think of words like points up, points down, and we always are going to read it from left to right. So think about it for a second, and then I'm going to tell you what I see, okay? All right, so when I'm looking at this, I see that this points down and this one points up. So I'm going to say that this one is down, up. Down, up. Looking at degree 2, I notice that this one's pointing up and this one's pointing up. So I'm going to call this one up, up. Points up, points up. And degree 3, pointing down, pointing up. Down, up. And a degree 4 polynomial, you are seeing, hopefully you're seeing that it's pointing up, up. All right, now you may notice that the degree 1 and the degree 3 are doing the exact same thing, and the degree 2 and the degree 4 are doing the exact same thing. And we're going to be playing with that in a few minutes, so let's just move on. Now let's compare these graphs. Now the only thing that I did that was differently is that I put that negative in front. Now remember from the parabola that negative flipped it over the x-axis. So, if we're drawing these, we're going to be flipping it over the x-axis. So I'm going to go ahead and just draw all my coordinate planes here. Again, it's just a quick sketch. Let me show you what happens. If I draw the negative, if I put the negative in front of the linear function, yes, it does flip it over. So it's a falling line versus a rising line. A parabola, we go from holding water to releasing water. It flips it over. The cubic function, again, it gets flipped over, it squiggles and goes down. And the quartic function, again, like this quadratic, but a little bit flatter at the end, like that. All right, now if I look at their end behavior, hopefully you're seeing now this one is up, down. Again, when I'm looking at the end behavior, I'm looking at kind of where the arrows are pointing. That's how I do it. All right, so this one would be going down, down. This one would be going up, down. And this one would be going down, down. All right. So what relationship do you see with the leading coefficient and the end behavior from the ones above? So the leading coefficient, when negative, flipped it over the x-axis. Flipped it so it reflected, there's the math word, reflected it over the x-axis. Okay? All right. So let's look at end behavior. So hopefully you saw that if it had an even degree, meaning like x squared, x to the fourth, and it had a positive leading coefficient, then the end behavior would be up, up. It's going to be important. If it was negative on that even degree, then it went down, down. So it had the same end behavior on both sides, okay? I'll put that same. Now the odd degree, so like x to the 1, x to the 3, and I could keep going, x to the 7th, x to the 101st, it had different end behavior. If the leading coefficient was positive, like x cubed, it went down, up. And if the leading coefficient was negative on those odd degrees, it went up, down. And that's going to help us when we sketch general graphs of polynomials. All right, so let's look at the examples of end behavior. Right here, I can tell you that this is a degree 2 polynomial and that the leading coefficient is negative. Why? Because it's going down, down. All right, this one is up, down, right? Which tells me it's an odd degree polynomial and it's a negative coefficient. All right, the one on the left, I can see it's going up, up. So I know that it's an even degree, which actually shows me it's an even degree polynomial, and the leading coefficient is positive. Now, this last one, you can see that it's going up, down. The leading coefficient would then be negative, which you see, and it would be an odd degree. Okay? All right, so hopefully I want you to spend some time just thinking about the end behavior of graphs, because tomorrow we're going to be looking at the end behavior, and then we're going to start looking at what happens in between the end behavior, meaning x-intercepts, y-intercepts, these squiggles that are going on, and everything else that appears on the polynomials. All right, guys, have a great night. I hope that helped.